So thank you very much for coming to this session about progressive delivery in the Kubernetes era. I'm going just to introduce you about progressive delivery and why it's important doing progressive delivery, and more specifically in Kubernetes. Okay, my name is Alex Soto. My tutor is Alex Soto B. I'm the co-author of multiple books, and if I will say that the book that is more, or is tackle more the progressive delivery problem is this one, the GitOps cookbook, that you can download it for free. If you go to developers.redhat.com, you go there, you register, and then you can download it for free. Then, so today, we're going to see a bit of why progressive delivery, what is progressive delivery. We'll see some of the techniques that we can apply, because at the end, progressive delivery, there's a lot of techniques. We're going just to see the more typical ones, then how to apply them in Kubernetes, and finally, some kind of wrap up. So what is really important to have in mind is that what is really important is have your code in production, okay? You can stay, if you're a developer, you're going to stay hours and hours discussing about what is the best framework to develop, let's do this pattern, this other pattern, and things like that. You can spend hours discussing with this, but at that time, your code is not producing any value. So the best place for your code is always production, okay? So how we can put this code into production, this is where progressive delivery comes. Maybe you are already doing continuous integration, and then continuous integration is this this blue part here, the light blue, where you build your application, then you test it. It doesn't matter, unit test, some component test, probably some kind of end-to-end test to validate the flow, all the the green path as well, security checks, so on. So like static code analysis, and finally you release. And this release, it's not releasing to production. It's like, okay, in the containers era, is like building the container and pushing into your image registry, right? This is the release of the continuous integration, and here finishes the, and this is where it finished the release phase. Then maybe you are also doing continuous delivery, okay? In the continuous delivery, there, you know that you run acceptance tests, more, bigger tests or longer tests, and basically you're probably running them in a staging environment, and then you move to production environment. So you deploy your application into some kind of, let's say, real environments. The problem here is, okay, and how we do this deploy. So yeah, we say, yeah, with continuous delivery, we're deploying. We are releasing our application, but how we can do that? Okay, yes, if you have some kind of, you're old enough, probably you've been doing like this. I mean, I did this in the past, like with FTP. You just, created a WAR file. You just connect to the server. You just find the libs directory. You copy there the WAR file, and done, right? This was the release phase. And then we say, oh, yes, but this isn't secure. So we're going to use rsync. With rsync, okay, it was more secure in this way, right? Okay, yes, you can do it. It worked. But of course, this is error prone. What's happened if you don't update all your servers, or you update the wrong server, or you copy, I don't know, a beta or or not tested application into a production environment? Things like that can happen because you were doing all these things manually. But then, of course, yeah, we said, oh yeah, but now it's Kubernetes. We've got kubectl, so I can do kubectl apply, and that's all. And that's true, right? But just keep in mind that if it sounds you weird doing an SSH or SCP to a server and copying the application there, doing kubectl apply of a YAML file is exactly the same thing, okay? You are just connecting to a cluster, and then you're doing kubectl apply, and yeah, let's hope that everything works, and yeah, it's exactly the same thing. It's a manual step that might be applied to the correct cluster or not. And what can happen if you do not control this a lot is just this kind of apocalypse, right? So you just do kubectl apply, you update an application, maybe just an application, but maybe you do a kubectl apply of bunch of YAML files, and well, yeah, all the application blows. And you might say, well, yes, but I'm not sure this can happen. Well, yeah, it can happen, right? I mean that. yeah, I mean, I was affected with this. I stayed like 4 days in Berlin because of this. So, I mean that I know that probably this problem is not related to Kubernetes or but the problem is in how they release the software, right? So they just said, okay, we've got a new version, let's update all the systems and let's see what's happened. Okay, it happened apocalypse, right? So this is why just copying a new version or just applying kubectl apply to a cluster of a new version, it might be not a very good idea. So what is progressive delivery after all? Well, as the name suggests, is that you are delivering progressively your application. There is no big bang. There is no, I've got version 1, here is version 2, just moved from version 1 to version 2. It's not like this. It's like, let's move step by step, right? Moving from V1 to V2. And one of the key concepts that you need to understand is that nowadays, deploy and release are different concepts. When I was starting, like 20 years ago, I said, hey, let's deploy to production or let's release this application to production. For me, it was like synonyms, okay? It was meaning the same thing. But nowadays, deploy and release is a different thing. Deploy is when you take your application and you put it into the production cluster. But you only deploy to production, but you are not sending public traffic. So no one knows that this application is running in production. And then it comes the release phase. And the release phase is when you say, okay, the application is running in my cluster. It seems that it's working correctly. Let's start sending public traffic to this new version. And this is when you start the release phase. And of course, you will know if this release works or not because you need metrics. And this is another really important part of progressive delivery, and it's the metrics. You need to know if your application is progressively working correctly or not, and you need metrics, okay? And these metrics can be technical metrics, for example, the number of 500 errors, or the number of errors, or the number of timeouts, or, these kind of things, but also can be business metrics. I will show you an example of how this is done by Netflix, okay? Netflix is doing progressive delivery, but it's using business metrics instead of technical metrics. Or maybe they are using both of them, but they are also using business metrics. And as I said, one of the most important things of progressive delivery is that you are not doing a big bang. You are just sending traffic to a subset of users. And this subset of users can be, randomly chosen, or maybe geolocation users. So you said, okay, let's start the delivery of this part of the wall. Or maybe it's like, okay, I have an agreement with this or with my customer that they are going to try the first, the latest versions, right? So it's like I've got this bunch of customers, but only these customers are going to test first the new application. So what is the advantages of this? First of all, you decreases the downtime. Okay, so if there is a downtime, okay, yeah, it can be, but you have everything automated. Right, you've got this deploy phase, this release phase. So if there is a problem in this release phase, you can always go back to the deploy phase. You also limit the tragedy, right? If you're just, sending traffic to a small group of users, then if there is something wrong, which can happen, it only affects this small amount group of users, not all your users, just these small ones. So a problem can happen, yes, but you're not going to affect everyone, just a small part of the people. And finally, when you're getting more proficiency on progressive delivery, you're going to be able to put to production faster, right? Because you're going to start getting confidence, saying, hey, look, this is working. And when it's not working, we are easily recovering, right? And we are not affecting all our customers, all our calls, just this small group. So it's a good thing. Let's move, let's go to production faster. And now it comes the question of, okay, how can I implement progressive delivery? Because it's nice to have progressive delivery. You're selling me progressive delivery. Yeah, the idea is really cool. But what techniques we've got in progressive delivery. And as I said, there are a lot of them. Here today, I'm going to explain you some of them, but if you start Googling, you'll see that there's a lot more. The first one, probably everyone knows about blue-green deployment, right? It's like, okay, it's like I've got my version 1, which is the blue one, and then when I want to switch to a new version, I just deploy the new version, and at some point, I decide that it's interesting to just move this router to this new version, so I'm releasing this new version. You see that it's an all or nothing. So I've got my version 1, I deploy the version 2, and at some point, I can do some tests in version 2, which is still not released, and at some point, I release the version 2, this green one. What is the big advantage of this is that you've got a quick rollback. So you can be in version 1, you change this router to version 2, and if you detect that there is a failure in the version 2, you can just quickly get back to version 1 because it's just changing these route rules, okay? Easy, but it has a problem. Is that if there is an error, this error affects all your users. You can recover it quickly, true, but you're affecting everyone. This technique comes a lot from the virtual machines era. It's something that probably you are not going to use in Kubernetes, but if you are using virtual machines, it's a really cool technique to use, okay? But again, it's affecting everyone. So then we've got the canary releases. Canary releases is something similar, which you've got version 1 and version 2, but now instead of sending all the traffic from version 1 to version 2, you are progressively sending traffic. So for example, you said, okay, let's send 90% of the traffic to version 1 and 10% of the traffic to version 2. And then, as I mentioned it before, you start reading the metrics. You're saying, okay, I'm sending 10% of the traffic to this new version. Are these 10% of the users behaving correctly, the version, so they have no more errors than the old version, the performance is okay, and all these kind of things? Yes, it's working correctly. Okay, then let's increase. Let's move from 90-10 to 80-20. And again, you monitor and you see these 20% of the users are behaving. Yes, okay, let's move to 70-30, 50-50, and so on, until you move all your users from V1 to V2. Okay? What is the interesting things here is what's happened when you've got a state. Because it's super, if your service is stateless, then it's super easy, right? You're sending a request to version 1, then you send the request to version 2. That's fine, there is no state. But when there is a state, things become more complicated. And this is where I recommend you using this kind of in-memory databases like InfiniSpan, Redis, and so on. Okay, these tools will help you a lot on managing the state in these situations. But of course, you see that if there is in this new version 2, there is an error okay, you've just sending 10% of the traffic to the version 2 and you detect an error, 10% of your users will get this error. Of course, if you've got like maybe 10 requests per second, that's fine. But if you've got like, I don't know, 1,000 requests per second, then 10% is a lot of requests that are going to fail. And some companies like Gmail, Amazon, and so on started creating what is known as dark launches. Basically, dark launches is a technique that let you, let's say, test your newer versions with public traffic, but your users will never know that you are using the traffic to test this new application. And I like to summarize it here like in 3 techniques. The first one is mirroring traffic. Suppose that you've got version 1 running here, and then I deploy version 2. What I'm going to do is just mirroring the traffic. Just saying, okay, I just get it a request, and I'm going to send the request to V1 and also to V2. But just see here the arrow, the arrows, okay? This is bidirectional and this is unidirectional, which means that the first one, I'm sending the request to the old version, this is version 1, I expect the response and I send back this response. So from the point of view of the user, nothing changes. But the same request is also sent to version 2. But I'm just getting this request, but I never send back a response. It's just a fire and forget request. Why? Because in this way, I can test if version 2 is behaving similarly as version 1 with the same request. So then I can just start comparing things like performance, error codes, and so on. I said, okay, I'm just sending this request. Yeah, it seems that version 2 is going to work. Yeah, I'm just checking the metrics. Everything works fine. And then you're going to start doing a canary release. Okay, so you do first the mirror traffic, and then you start the canary release. There is another technique, which is named dark canaries, which basically you send the traffic to this new version, but instead of doing randomly, like in the canary release, where you are just setting a percentage, and you randomly select a percentage of users and send it to version 1, here you did in a more, let's say, controlled way. Usually you set a flag, and depending on this flag, you send the request to one version or to another version. Okay, for example, you can say, let's suppose that you're working in Facebook, okay? And I said, I'm an employee of Facebook. So if I'm an employee of Facebook, then I send the traffic to the newest version. So the employees of Facebook could start testing this version 2 as well, okay? Or, for example, if you got an agreement with your customer, I don't know, Acme, for example, said, hey, I've got an agreement with customer Acme that they are going to help me, or we're going to provide the latest version. So you can put this kind of flag saying, okay, if the customer equal Acme, then go to the version 2, if not, go to the version 1. You can just monitor both versions, and when you feel comfortable with it, you can start doing the progressive delivery. Okay, and of course there is also future flags, which, okay, maybe it's the technique that I didn't like it a lot, because you need to start putting some, or modifying your code. All these techniques that I'm explaining here, the code is not changed. In the case of future flags, okay, you still, need to change the code, manage the code in some way. So it's a technique that I prefer to not use. So just keep in mind that if you're trying to say this, oh, progressive delivery is super cool, I think I should, introduce to my manager, keep in mind that you are starting doing testing in production. Because as you can see, we are just deploying, right, to production servers, and then we are testing this solution in this cluster, okay? Of course, we are not releasing, so we are not sending public traffic to this new version, but you are running your tests on production cluster. So, as I said here, production is not sacrosanct anymore. And there is a lot of to talk about testing in production. We have, you have no time, but you can see that one of the important points here is the monitoring. As I'm saying all the time, we need to monitor our solutions. And this is an example that I mentioned before of Netflix. This is a, is a monitor system of Netflix. And basically here, it's the number of times that user pushes, or the users pushes the play button. Okay, you can see that here there is like red and there is a black. Basically, this is version 1 and this is version 2. And you can see that users can push the play button and it works in, in the same frequency. So it seems that both versions are working correctly. So it means that, okay, I have users in version 1, I have users in version 2, and both users can just push play button and it works in the same way. So it means that I can start the transition from version 1 to version 2. Okay? If you could see here a different graph, then it means that one of these two versions are not performing equally. So how I can do this in Kubernetes? Because at the end it's like, okay, we want to do this in Kubernetes, how I can do it? Okay, blue-green deployment, well, it's fairly easy to do. You have this selector
field in the service, where I say in service my app v1, for example, and then in my deployment, the v1, the service v1, I can just put here the label app my app v1. And when I want to switch to the green, I can just do kubectl label pod -l app my Python, which is the new application. And I said, or the new version of the application, I said in service my app v2. Then I change in the service, I change in the pod, that's fine, all works, okay? But how can I do a canary release? Oh yeah, I can do this, right? I can just say, hey, I want to send 75% of the traffic to v1 and 25% of the traffic to v2. So I'm just going to do kubectl scale to replicas 3 and kubectl scale to replicas 1. And yeah, okay. Yeah, it works. But probably this is not what you are expecting. What happened if I told you that you could just do this using a YAML file like this, okay? I just put here a kind of name virtual service, and then I said, look, I've got a service named recommendation, and I've got two versions of recommendation, version 1 and version 2, and I want to send 75% of the traffic to version 1 and 25% of the traffic to version 2. Yeah, much better, right, than doing kubectl scale. And you can just put here the number that you want. You can put 80-20, 50-50, 60-40, and so on. Shadowing traffic, okay, how I can do this shadowing traffic? Remember that shadowing traffic is this mirroring traffic that is sending the one request to version 1 and the same request to version 2, but the version 1 does a request and gets a response, while the version 2 just sends a fire and forget request. How can I implement this? Well, you could do it in this way, right? It seems really visible. You say, hey, look, I've got a service recommendation. This is the version 1, and I want to mirror the request from version 1 to version 2 as well. Easy to do. It's just a YAML file, and you do not need to implement anything on your own. And the same with the dark canaries. I could say, hey, look, if I've got a header named end user, if in the name end user is Alexandra, then send it to v2. If not, send it to v1. Easy to implement. It's just a YAML file. I explain what I want to do, and then it will be great if Kubernetes could understand this. And this is exactly what you get with Istio. Okay, Istio is a service mesh. It's been here for a long, long time. Basically, it's code independent, so you just install Istio in Kubernetes and it works with any framework, any language, or whatever. Okay, it can be used for a lot of things, as you can see here, for security, observability, resiliency, for doing chaos testing as well. But for what we are interested here is for intelligent routing and load balancing. And this is exactly what Istio does. The YAML files that I showed you before are Istio YAML files. It just, you do a kubectl apply of these YAML files, and Istio will do the rest. And it works thanks of sidecar containers, because now when you deploy your application, you're deploying the application, the service. In this case, you can see here service A, service B, service C, but you're also installing a sidecar container. So you're just putting your pod with two containers, your service, and the Istio container. And this new container is the one that is going to intercept all the traffic. So every time that I want to do a call between service A and service B, the call will go through service A to the sidecar container of service A. This sidecar container of service A will go through sidecar container of service B, which at the same time will send the traffic to service B, and so on. Okay, so everything is intercepted by this container. So every time that I apply some of these YAML Istio files, this side container is configured to route the traffic correctly. So if you want, you can scan this application, which you'll see that there is some kind of color bubbles. Okay, you'll see now. I will show you in a few moments. I'm going to scan it as well. Where is? Okay, then in case that you are, I'm going to copy, I think that it's this one. bubbles index. Okay, so if you're on the scanner, you'll see this. Basically, you'll see red balloons. Now, how can I change this to, for example, blue balloon? So I want to go from version 1 to version 2. I can, as I said before, apply this YAML file, which is here, this one. I'm just saying, okay, I've got a bubble service, I've got 2 versions, and I want to send 0% of the traffic to version 1 and 100% of the traffic to version 2. So I'm going to do kubectl apply -f bubbles backend source main resources Istio. Oops, it's not in source main Istio, and I can just send virtual service bubble backend b1. Okay, I think that it will be easier if I remove and I just do a copy paste. Okay, now I'm just sending all the traffic to V2, okay? So now if I get back here, you see that now I'm getting only blue, okay? I could just do the same thing, for example, with, let me delete this, with V2, and V2, 75% to V1, 25% to V2. So I'm just sending 75% of the traffic to the red balloons and 25 to the blue balloons. So if I go here, you see that now I'm just getting some more reds than blues, but I'm just getting both of them. Now I'm just going to play another one, which is it's one that is quite kind of interesting example. I'm just going to send this, and basically now in my phone I've got blues, okay? I don't know if everyone has a blue. Here I've got reds, okay? You see that I've got different things. Here are blues, here is red. Basically what I'm doing here is doing, what is the mirroring? Here. Oh, I can show you here better. And I'm doing this. Basically I'm just, this is the mirroring, sorry, it's here. I'm just saying, hey, if the user agent is Chrome, then send to V1. If not, send to V2. So I'm just playing, for example, with the browser. And you see that I've not deployed anything. My application is always the same. It's always the same. I can do kubectl get pod. And you see that it's been here for 3 hours. The application is the same. The only thing that I'm changing is how I'm delivering the application. So I'm deploying the application. I've got here deployed bubble backend V1, V2 on the front end. They're deployed, and I'm just changing the release process. I'm just applying YAML files. But then, the next question is, I've just delivered, a lot of Istio talks, and it's like, okay, how can I automate this? Because you've seen that I've just do it a kubectl apply of, 75, 25%, 50, 50, and so on. So I'm just putting this percentage. How I can automate this? And the answer is Argo Rollouts. Argo Rollouts is it's a project from Argo. So if you know ArgoCD for deploying automatically, so this is exactly, that is from the same open source community that basically changes the Istio percentage automatically depending on the metrics. So you can just install, I don't know, for example, Prometheus, Datadog, or whatever, any of the monitor tool that you've got, and then you install Argo Rollouts, you install Istio, and then say, hey, this is the application, just let's start a rollout. And basically, it's increasing this percentage automatically depending if the metrics are behaving similarly or not. And this is how you do. First, the first thing that you will notice here is that I'm not using a deployment kind, it's a rollout kind. Okay, the rollout is like a deployment, it's It's following the same structure as you can see here, but it's a bit different, okay? Because you're setting here the steps of the canary. In this case, I'm just doing a canary, which is like, okay, let's just start with sending 20% to version 1, 20% to version 2, 80 to the version 1. Then after 1 minute, let's wait if 1 minute everything works as expected. And if everything works as expected, then let's move to 50-50. Let's wait 2 minutes and then move to 100%. And this happens automatically. Now, let me just go here. I'm going to wait. Hope I've got time for everything. Now I'm deploying the previous example, and I'm just going to install the new one. Here you can see that there is a lot of examples with Argo and so on. Let's do without metrics to go faster, and let's go to deploy. So now I'm just oops. Oh yeah. Wait. Let me do one thing. I think, wait. I thought that I already fixed this. Oops. It's because of, let me check the path. Okay, if not, probably I miss one dot. Let me hope that it's this thing, but if not, no worries, because I will share with you a link to reproduce everything, but okay. Now, I'm just deploying the same example, but in this case, I'm just putting v1. Okay, I'm just having here v1. So if I go to this example again, you'll see that, well, now it's been deployed, so it's not deployed yet. Let's say, okay, get pods, maybe they are running. Okay, in theory, it's the same. Oh, maybe. Okay, now I've got only the version 1, and when I want to do a rolling update to version 2, I've got here, I've got this script, which I don't know if I will need. Yeah, probably I will need to also fix this. Oops. This is what happens when you've got different computers to work. Okay, now it's configured and it's still v1, that's fine. But here I've got this command. You can run this command here that basically will explain you how it's going. Okay, you see that it say, okay, I've got revision 1, and now I'm starting the rolling update to version 2. You see here, it's it's how it's working. Now if I go here and I go in this tool, you see that I'm getting a lot of reds and some blues. If I do kubectl get virtual services, you see that I've got this backend virtual service, and if I do get virtual service, this means YAML, you see that now it says that it's 80-20. Remember that I put it 80-20 in the initial YAML file here. This is the initial one. I'll show you. Well, now if we wait, you'll see how this is changing. Okay, but still it's we run, you know, and now it's 50-50. You have not done anything, and I went from 80-20 to 50-50. And finally, last thing I want to show you, which basically is that if you want to reproduce everything that I've shown you here, you can just go to this QR code or github.com/Red Hat Developers Demos Bubbles Progressive Delivery, and you'll have all these examples that I show you so you can reproduce in Minikube or in your Kubernetes cluster. So thank you very much.